All right, we're going to talk more about the conditional today. We're going to first start talking about some alternative forms of the conditional, so some other ways that you can write the same statement and it would still be a conditional statement, just different ways of writing it. We're going to talk about different statements that are related to the conditional. We'll talk about the converse, the inverse, and the contrapositive. We'll talk about what a biconditional is. And then we'll sort of summarize all our basic truth tables that we've done up to this point. All right, so let's start off by going over some alternative forms of the conditional. So we have P arrow Q, right? Common translations of this. So the first one is if P, then Q. We can also say P is sufficient for Q. You can say if P, comma, Q, like without the then. You can say Q is necessary for P. We can say P implies Q. We can say all P's are Q's. P only if Q. Q if P. And Q when P. Now, the different ways that we translate this conditional statement doesn't depend on whether or not P implies Q is true or false. Okay, so the different translations of P implies Q does not depend on the truth or falsity of P implies Q. Okay, so let's take an actual written out statement, a conditional statement, and see if we can write it in all these different ways. So here's the statement. If you answer this survey, then you will be entered in the drawing. Okay, so the way that it's already written right now is if P, then Q, right? So you know which one is P, you know which one is Q. So now with all those different equivalent ways of writing it, we'll just go ahead and translate and write this conditional statement. So you can write it without the then. So if you answer this survey, you will be entered in the drawing. Okay, we can say P implies Q. So answering this survey implies that you will be entered in the drawing. We can say P only if Q. So that would be you answer this survey only if you will be entered in the drawing. Right, we can do Q when P. So that will be you will be entered in the drawing when you answer this survey. We can say P is sufficient for Q. So answering the survey is sufficient for you to be entered in the drawing. Q is necessary for P. So being entered in the drawing is necessary for you to answer this survey. All P's are Q's. So all who answer this survey will be entered in the drawing. And lastly, Q, if P, you will be entered in the drawing if you answer this survey. Okay, so tons of different ways that you can write the same conditional statement. These are all equivalent to each other. All right, so now let's take a look at the next example. This one, these are all written in different forms, but we're going to try to translate them into the form if P, comma, then Q. Okay, so possession of a valid identification card is necessary for admission. Okay, so determine which one's P, which one's Q, which one is the antecedent, which one is the consequent. So possession of a valid identification card is necessary for admission. We can write this as if you are admitted, then you possess a valid identification card. All right, you should use this door only if there is an emergency. All right, so this one we would say if, so determine which one is your antecedent. So if you should use this door then there is an emergency. Okay, this one's a little bit tricky because you see the if there, so you automatically start thinking that that must be the if part. But this is only if. So if you go back to the statements that you wrote down earlier, it's P only if Q. Okay, so P, C, antecedent, Q is consequent, so if you should use the store, then there is an emergency. All right, last one. All who are weary can come and rest. Okay, so remember this one is the all P's are Q's, right? So if you are weary, then you can come and rest. All right, let's take a look at the next example and give us a little bit of practice working with the symbols. So let R represent a triangle is a right triangle, and S represent the sum of the squares of the two sides equals the square of the hypotenuse. Okay, all of that is just to say that a squared plus b squared equals c squared is true. Okay, so the sum of the squares of the two sides equals the square of the hypotenuse. Write each statement in symbols. Okay, a triangle is a right triangle if the sum of the squares of the two sides equals the square of the hypotenuse. Okay, so notice how this one doesn't have only if, it just says if. So a triangle is a right triangle if the sum of the squares of the two sides equals the square of the hypotenuse. So you can see this as Q if P. So if we are trying to write this in terms of S and R, so R is the first statement, so it's R if S. So if we were to write this as which one implies which, this would be S implies R. So if S is true, so if the sum of the squares of the two sides equals the square of the hypotenuse, then a triangle is a right triangle. All right, the second one, a triangle is a right triangle only if the sum of the squares of the two sides equals the square of the hypotenuse. Okay, so this one has the only if part. Okay, so if you see this, remember this is, if you go back to that very first slide that we had on alternative forms, right? The only if was P only if Q. That means the first statement implies the second statement, right? Okay, so a triangle is a right triangle. That's R. Only if implies the sum of the squares of the two sides equals the square of the hypotenuse. That's S. So in this case, it's R implies S. So you can see how the only thing that's changed, the only thing that's changed is the word only. Okay, so just be aware, be really careful with the alternative forms and what they actually mean. All right, the next part that we're going to go over are what we call the converse, the inverse, and the contrapositive. So just because you have a conditional statement, P implies Q, or if P then Q, there are other statements that you can create, which are these three, that could be true, could be not true. So we'll go over this. So the original statement, if the original statement is P implies Q, which is kind of the most basic form of the conditional. So we're kind of ignoring alternative forms right now, just P implies Q. Then the converse statement is if Q, then P. Now in mathematics, sometimes it's true that if P, then Q is true, but it's not always the case that if Q, then P is true. Sometimes it is, sometimes it isn't. So that's kind of where we're going into the realm of how this applies to mathematics. How do we know if something is true? Can we tell whether or not its converse will also be true? Okay, so for example, the Pythagorean theorem, for example, is an example where the original statement and the converse are true. So if you have a squared plus b squared equals c squared, then you know it's a right triangle. If you have a right triangle, then you know a squared plus b squared equals c squared. So that's an example where the statement and the converse are both true. Okay, next we have the inverse. The inverse is if not p, then not q. Okay, so negating both p and q in the original statement. Okay, and you might be able to guess what that last one is, the contrapositive. You are negating both p and q in the converse. So not q implies not p. Okay, so let's go over what is going to be true, what is going to be false. Okay, so let's start off with your usual P and Q. So true, 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 false, false, true, false, false. And then let's go through each of these. So the original statement, P implies Q, well, we actually already know this, right? It's only going to be false if P is true and Q is false. So true, false, true, true. All right, so the rest of these are just conditionals, but we're just switching which one's the antecedent, which one's the consequent. So Q implies P. So remember, the only time where this is going to be false is if the first statement is true and the second statement is false. So this is going to be true, true, false, true, right? We're going the other direction. All right, next one. Not P, then not Q. So again, the one place where this is going to be false is if you have a true statement implying a false statement. So be really careful. If you need to write down what not P and not Q are, feel free to do that. But if you look there in the third column, right, the opposite of false is true. So not P is true, not Q is false in the third row. So that's going to be the one place where it's going to be false. Okay, and then the last one. Not Q implies not P. So again, the only place where this is going to be false is if you have a true statement implying a false statement. Okay, so if we're looking at the Q column, right, not Q is true in that second row, and not P is false in that first column there in the second row. So this is going to be false on that second row, but true everywhere else. True, false, true, true. All right, let's keep going. So let's take a look at example 4. Consider the following statement. If Catherine is a cat, then Catherine is a mammal. All right, write each of the following. So you're not deciding whether or not it's true or false right now. You're just practicing writing the converse statement, the inverse statement, the contrapositive. Okay, so the converse, you're just flipping P and Q. The converse would be if Catherine is a mammal, then Catherine is a cat. Now you can probably already start to think about whether or not it's true or false, but really just now we're just writing out what the statement would be, practicing how we would write it. Okay, the inverse. Now this one is where we negate the original statement, not P, then not Q, right? So this is if Catherine is not a cat, then Catherine is not a mammal. And then the contrapositive, you negate each of the statements in the converse. So if Catherine is not a mammal, then Catherine is not a cat. Okay, so the next thing we're going to talk about is what a biconditional is. Okay, so a biconditional is when both P implies Q and Q implies P are true. Okay, so in other words, this is where the original conditional statement and its converse are both true. Another way to write this, instead of writing P implies Q and Q implies P, is just to simply write an arrow that faces in both directions, points to both P and Q. Okay, so with our usual P and Q filled out here, true, 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 false, false, true, false, false. Remember that the one place in which P implies Q is going to be false is when you have a true statement followed by a false statement. And for Q implies P, same thing is true. When Q is true and P is false, that is also going to be false. So for a biconditional, this is going to be true when both are true, false when just one of them is false, and then it's going to be true when they are both false. All right, take a look at example 5. Tell whether each statement is true or false. George Washington is the first president of the United States if and only if John Adams is the second president of the United States. Okay, so that if and only if means it's a biconditional. Okay, so this means that if George Washington is the president of the United States, is the first president of the United States, then John Adams is the second president of the United States. It also means if John Adams is the second president of the United States, then George Washington is the first president of the United States. Okay, so since both of those statements are true, we know that this is going to be true. Okay, Alaska is one of the original 13 states if and only if kangaroos can fly. Okay, look at each statement. Alaska is one of the original 13 states. It is most certainly not, so that is going to be a false statement. Kangaroos can fly. That is also false. So if both are false, then for our biconditional, since we see that if and only if in there, this is going to be true. All right, last one, 2 plus 2 equals 4. If and only if 7 is greater than 10, the first statement is true. The second statement is false. So if we have one true, one false, we know that this is going to be false. Okay, so a summary of all the basic truth tables that we've gone over up to this point. We're going to summarize it here. Hopefully this will be helpful, putting it together for everyone. So negation, this is when you have not P. It has the truth value that is opposite whatever P is. All right, a conjunction, this is when we have and, so P and Q. This is true only when both P and Q are true. Okay, a disjunction, P or Q, is false only when both P and Q are false. Right, otherwise it's true. So the only time it's false is if they are both false. The conditional, P implies Q. This is false only when P is true and Q is false. Okay, otherwise it's true. So it's only false when P is true, Q is false. And the biconditional, the last one we just did, where P, if and only if Q, this is true only when P and Q have the same truth value. Okay, so if they're both true, then it's true. If it's both false, then it's also true. Otherwise, it is going to be false. All right, and that is all we have for today.